Hey, Brooke.
Hey,
I can barely hear you. There's a huge echo.
yeah, I
But if
can.
you want me to just start working through the review, I can do that. Can you hear me okay?
Yeah, I can hear you fine.
Okay. You
Okay.
start out good and then it kind of fades and
Yeah.
sounds like you're in a tunnel. So
Yeah.
I will try to toggle back and forth. So if you just say my name, then I'll know to
Okay.
come back over to the Google Hangout screen to see if you have a question. But I'll just start working through the review. Does that sound good?
That sounds perfect.
Okay, sweetheart. um, on the review, the first thing that I have you guys doing is identifying A, B, and C. Because if you
Yeah.
can knock that out, it's a good idea because then you know for sure, that you're going to plug in the right values. And if you start with the wrong values, you're going to get the wrong vertex and axis of symmetry. So A is a -6. No, I lied right off the bat. That's why you need to find A, B, and C. A is 1. B is -6. And C is 13. So the axis of symmetry is the opposite of B over 2A. So I'm going to take the opposite of B, opposite of -6, all over 2 times 1. So that's going to reduce to 6 over 2, which then reduces to 3. So x equals 3. That's going to be my axis of symmetry. So it's going to go on the graph just like this. And now to find the actual vertex, I'm going to plug that 3 back into the original equation, which is going to give me 3 squared minus 6 times 3 plus 13. So that gives me 9 minus 18 plus 13. So 9 minus 18 is -9 plus 13 equals 4 because I find the difference and give the sign of the higher. So the vertex is going to be 3, 4. So it's going to be right there. So now what I would do to find just a couple of other points, I'd first want to look and see if the y-intercept is doable on the graph, and the y-intercept is going to be 13, so not quite doable. So I'll just do a little table. And I've got 3 and 4 as my vertex. And so what I would do just for simplicity's sake is pick a point above or below. So I'm just going to pick 2 and plug that back in. Well, sure you are. That's going to be 4 minus 12 plus 13. So that's going to give me 4 minus 12 is -8 plus 13 is 5. So I'm going to plot that at 2, up 5. And because of the law of symmetry with regard to a parabola, then I actually know that if I went down 1, that should also give me a 5. So I've got 3 points and I'm good to go.
Okay.
So easy enough. Not too bad, not too bad.
Not too bad.
All right, so the next one. Oh, I didn't ask this on here, but just to emphasize this, Brooke, if you
Yes.
were ever asked about the minimum or maximum, this would be a minimum
Yeah.
because the point goes no lower than that, and the value of the minimum is that 4. It's the y value in the problem,
Right.
in the vertex. Okay, does that make sense?
Yes,
Okay,
ma'am.
good. All right. I may need this area, so that's why I'm erasing this.
Oh yeah.
I need all the space I think I can get on these.
Yeah.
Okay, so identifying A, B, and C once again. It's -1, and then 8, and -21. So once again, using the opposite of B over 2A, I'm going to plug in the opposite of 8 all over 2 times a -1. That's going to give me -8 over -2, which results in a +4. So my axis of symmetry is x equals 4. And to find the y value for my vertex, I'll take that 4 and plug it back into the equation. Which is going to be 4, the opposite of 4 squared plus 8 times 4 minus 21. So opposite of 16 plus 32 minus 21. So it's going to be 16 minus 21, which results into a -5. So my vertex for this one is 4, -5. And I also know that my parabola is going to be a frowny face parabola based on the A being a negative.
Right.
What I'm going to do is go up or down 1 from my vertex. So I'm just going to pick a 3. To get another point. And 3 squared is 9. Whoops, I shouldn't have put it that way. I apologize. I kind of gave the result instead of just putting it in there. I'm very sorry. So
It's
the
okay.
opposite of 9 plus 24 minus 21. So -9 and 24, that's going to be 25 minus 21. Yes, is that right? Did I do that right? No, I did that
No.
completely wrong. That's 15. My bad.
That's okay.
15 minus 21, which is a -6. I'm sorry about that. Okay, so so it's a +3 and then down 6. And once again, if I were to go over to 5, I would probably, because of the property of symmetry in a parabola, probably be 5. So my parabola is going to look like this. Okay. Any questions about that?
No.
You feel pretty good about those?
Yeah, I was wondering, I have to go in a couple minutes to physical therapy. So I was wondering if you could do like number probably like number 9 and number 17.
Absolutely.
Okay.
Yes, I sure can.
Just so
Love
I
to.
have samples so I know how to do the rest when I get back home.
Absolutely, sweetheart. I'll be happy to. Okay. So what I need to do in order to solve these is I need to get it in standard form in order to factor them and solve. So I'm going to bring this 3x over to this other side.
Okay.
Like that. And then I would have x squared plus 3x minus 10 equals 0.
Yes.
And then I'm going to factor it like normal. So what I'm thinking of is what two factors multiply together to give me, and do you want me to do this by grouping, or are you okay with just factors?
What do you mean by grouping?
Like when I think she does it like this, when you find the two factors of 10 that add to be 3. So I would have like plus 5x. Actually, let me do it this way. When she does the grouping, I think this is how she taught it. So minus, well, heavens, help me, please. Minus 2x plus 5x minus 10. Did she do it that way?
Yeah.
And then group, you want me to do it that way?
Yeah.
Okay. All right. Okay, so then you can factor out an x here.
Right.
And here I can factor out, oops, my bad. I can factor out a 5. Then my two factors are x plus 5, x minus 2 equals 0. And then you would set each one of those equal to 0. So x equals negative 5, and x minus 2 equals 0, x equals 2. So your final answers are negative 5 and 2.
Okay.
Does that make sense?
Yes, ma'am.
Okay, good. Let me erase this. And you wanted me to do what number was it, sweetheart?
Can you actually do 18?
I can.
Okay.
I'm not going to bother to erase that. I'm just going to move since you're in a hurry.
Yeah, it's okay though.
All right. So on these, this I can tell is one of the special factoring patterns because the first term is a perfect square.
Okay.
And the last term is a perfect square.
Right.
And that what is the perfect square of 25n squared?
Is it 5?
N.
5.
Mm-hmm.
Yeah.
And what is the perfect square of 4?
2.
Right. All right. If I multiply 5 times 2, what do you get?
10.
And then if you add 10n together, what do you get? 2 10n's.
10n and 10n is 20n.
So, and that's that middle term.
Right.
So the answer is 5n plus 2.
Okay.
Does that make sense?
Yes, it does.
And like here would be, since this is a minus, you would take the perfect square of the first term and a perfect square of the second term and then put a minus in the middle. And just to double check, I always go 4n times 3 is a negative 12n. And if I add another one to it, it's negative 24.
Okay, perfect.
Just to make sure that I've got it correct. And then number 16, this is one of the difference of two squares. So that's 2p plus 5 and 2p minus 5.
Okay.
That's just kind of the difference of those.
Yeah.
Is there any other ones?
I don't think so. I think with that, I can figure out the rest of them. And then, can I email you if I have any more questions later?
Oh, absolutely, you can. Okay, absolutely.
I will definitely do that if I have another question later.
Okay. Yeah, I'll be happy to work with you. And when you get back, if you need me to, I can set up a Google chat with you and we can work a few out. You can just write down the ones you want me to specifically address, and we'll do that, okay?
Okay, that sounds good. Thank you so much.
You're most welcome. Good
Bye.
luck on physical therapy.
Thank you.
All right. Bye-bye. Hey, Braden.
Hi, Miss Sparks.
Do you want me to start? When did you get on, buddy?
Oh, I got in like 5 minutes ago.
Okay. Did you get to see me do any of the graphing ones?
No, ma'am, I did not.
Okay. Do you want me to start at the beginning?
Wait, did you hand this out on Friday?
Yes, sir.
Oh, I didn't get one because I don't remember you handing one out. I also texted Madison and she said that you didn't hand one out.
I did because it was the first thing I handed out, and I said, "This is Tuesday's work." And most everybody put it in the binder.
Let me see. Hold on. Let me see if I have it. Because I don't believe I do. Anyway, I don't believe I have it at all. Uh-oh. Oh, I think oh wait, it could be right here actually. Oh, here we go. We
Yeah,
had
because I was going to say, I did that before I started class.
yeah, I was freaking out. That's what you said. Oh wait, I got 2 of them.
One should say test 1.1 through 1.4 review, and the other should say test 1.1 through 1.4 review graphs only.
Yeah, I have both of those.
Yeah.
Okay, so okay.
It was just to give you extra practice on the graphing because some of you seem to struggle with that. So I was going to go through both of those.
Okay, and you said there's going to be no fractions whatsoever on this thing, on the test tomorrow?
Well, I'm not going to put fractions in the graphing part, but
Oh, okay.
I'm not going to say, like, you know how sometimes
Well, yeah, like I
when
was
you
doing
factor,
fractions today. Yeah, like when you factor, you're most likely to get a fraction sometimes.
like your end result could be a fraction, you know, like
Yeah.
let's say it's 2x, your factor is 2x minus 1, then obviously it's going to be x equals 1/2.
Yes,
You know what
ma'am.
I'm saying? I'm not promising that wouldn't be on there, but I didn't put any. I don't think any of the axes of symmetry, et cetera, have.
Yeah, I get what you're saying.
Okay, I'm going to just double check now that we're on here, and I said that, and I'm like, oh, what if I did? I don't think I did though, so I'm pretty good about double checking that because I like for there to be fractions in the homework because I don't want y'all to lose the habit of. Oh no, wrong chapter 1 test. Y'all would cry. And last year we gave chapter 1 test and it was all 8 sections.
Oh, really?
Yes. And we
Yeah,
decided that was not a very good idea.
I don't think I would survive that at all.
Yeah.
This is a lot of information.
There is. There's a lot of information on 1.1 through 1.4. You know what I mean?
Yes, ma'am.
No fractions thus far. No fractions on the graphing.
Thank you.
It's all pretty.
Awesome. So for sorry, I'm looking through this. I'm trying to.
You're fine. You're fine. I'd rather you ask me specific questions.
Yeah. Would you be willing to go back to 1.2 practice B or practice A? Just one thing on that.
Absolutely. I'm willing to do whatever you need me to do. That's what I'm here for.
Awesome. Thank you.
Oh, not a problem. Let me just make sure that I've got that pulled up. I was trying to pull up a variety of worksheets. to be prepared.
Yeah.
I think it's this one. $1.2 though, the back side, correct?
Yes, ma'am. It's the 1.1 and then the 1.2. It's like
Yes, sir.
practice B and then practice A or whatever.
Yes, sir. I think I know exactly what you're talking about. It's this one, right?
Yep.
Okay.
Um,
Let me erase some of this good stuff in case it's not your question.
Basically, I don't know. Oh, wait. You have a different problem. Oh, no, you don't. No, you don't. Never mind. How I'm kind of confused on how you find the vertex and axis of symmetry for like number 4 and like those numbers.
Okay. That's just like the parent graph that we started the school year with. So the vertex is already there. Remember in the parent graphs how this right here,
Yes, ma'am.
you're going left or right one, and in this
Oh,
case
yeah.
you'd be going right one.
Uh-huh.
So right one, and then this tells me to go up one. Right?
Well, I understand how to
There's
graph it. I just don't understand how to find the vertex and axis of. Well, I mean, the axis of
that's
symmetry
it.
is equal.
That's the vertex. That's the vertex. That's what I'm giving you. That's how
Oh,
you knew to go right one and up one. That is the vertex. Does that make sense? So it's
okay.
1. That's the vertex. And then the axis of symmetry is always the x of the vertex. So it's x equals 1. Like
Oh,
that. Does that make sense?
yes, ma'am. That's a lot easier. See, on the
Yes.
front page, I was like doing a bunch of junk to like, I was doing it a totally hard
Yes.
way.
Well, no, the standard you have to plug into the formula.
Oh, okay. So I was doing it
When you
right.
have the standard, when you have one that's like this, you have to use that opposite of B over 2A.
Yeah, and then you
But what
also
we
have
don't
to.
want you to do, we want you to be able to recognize something like that
Yes, ma'am.
as the parent function shifted down 3. That's all that is.
Yeah.
Okay. And this, essentially, you could factor, this, you don't have a C here. So you've got 4, the opposite of 4 over -2. So that's going to be 2 on number 11. You know what I'm saying?
Yes,
Does
ma'am.
that make sense? Or you can even, so you've got, and then you would plug in that 2 back in to get your Y value.
Yeah, I got all those worked out and stuff.
Oh, okay.
I understand the
But
front page. I was just
the
kind of
only
confused.
reason I threw in 1.2 was
Hmm.
because 1.2 was just to remind you that this is parent function. And
Okay.
that's all that is.
So what will be on the test? Like could you just like give me a list of
It
the
is
things?
exactly, like I said, it is exactly this same everything. Like number 1 and 2 will be in standard format and you will graph them.
Okay,
Number
so
3 and 4, one of them is in this parent function form right here. That's parent function form. So you know it's going to be shifted right 5 and up 1. So right 5, up 1. So your vertex is there, your axis of symmetry is there, and then plot a couple points, sketch the graph.
basically what you're saying is the test 1.4 through 1.1 through 1.4 review, that is going to be what the test looks like.
Is exactly what the test looks like with different numbers.
Yes.
That's why I give it. If you can work through this, you can do the test.
You didn't want to give us the same numbers?
No, I didn't want to give you the same numbers.
Oh, darn it.
But this is it exactly.
Okay.
And
All
I
right,
only
so
gave you additional graph ones so that you all would be comfortable with that part. Because I
yes.
thought there was plenty of opportunity to work on the factoring between all the worksheets. I just wasn't sure if there was enough opportunity to really review the graphing. So I gave you 4 additional of those to make sure you knew what you were doing. And
Yes,
so all I did really essentially is regenerate that and just took off all the graphing problems. But it is exactly like this.
awesome. So, could we do uh could we work on the review sheet?
Absolutely. That's why I had it pulled up.
Okay.
And number 1 is I kind of sort of have done there. This is actually the T chart though for number 2. But what
Yes.
I did is I found the vertex. I identified A, B, and C, which is the first part, the first instruction. And I say to do that, it's part of obviously the problem, and you'll miss it if you don't have it written down like I have here.
Yes, ma'am.
But I do that to make sure that you're plugging in all of the right numbers into your opposite of B over 2A.
Okay.
Okay?
Yes, ma'am. So for the assignment sheet and stuff,
Yes.
um, your one is if okay, for the quilt thing, especially, do I have to color that in or no?
A lot of people ask that question, and I said if you don't want to color it in, that's fine. Just make sure you have all the factoring. And the reason why I hound on factoring is because you are going to have a lot of that in pre-calc, and you're also going to have it in calc. But it's in trig identities, it's in everything. So the better you know how to factor, and the more quickly you can do it, the better off you're going to be.
And as well as the 1.3 through 1.4 solving quadratic equations by factoring coloring activity, do I have to color that one in as well? Or is it the same thing?
I was hoping one of the 2 would be colored. So if you have one that's a favor, yes, I would like one of them. I just don't want it to be too much, you know? I
Yes,
didn't think that one was too bad, was it? Was it a lot?
I mean, there's already just like so much work, and I mean, I think I'll do the quilt one. The quilt one looks easier.
Okay.
So just have one or the other kind of deal.
Yes.
Okay. Alrighty.
So do you want me to work through this or not?
Yes, please. If we could just go through, I don't. If you
Do you
don't
want to go
mind,
through the factoring part or you want the graphing too?
um, could we start with the graphing?
Yeah.
Like, could we just maybe just run through 1 through however many problems are on this thing? 20.
Yeah. Okay. So A equals 1. You have it in front of you?
Yes, ma'am, I do.
Okay. So A equals 1, B equals -6, and C is 13. So I'm
Yes.
going to plug in the opposite of -6 all over 2 times 1. So that gives me 6 over 2, which equals 3. So my vertex, my AOS or axis of symmetry is x equals 3. And in order to get my y value, which also will be my minimum or my maximum value, I will substitute that 3 back into the equation.
Okay.
Okay, so I have y equals, and then 3 squared minus 6 times 3 plus 13. So I've got 9 minus 18 plus 13. So I got -9 plus 13. So my vertex is 3, 4. And so what I typically do is go up 1 and I would substitute that back in to figure out one other point, because I need about 3 points to graph this. So I've got my axis of symmetry. I've got my vertex. So if I plug in a 2 here.
Oh, wait, I do have one question, actually.
Okay.
Okay. For us to find the other point of the vertex, we got to plug it in with 3 to all the whole thing. Do we, right where you have 2 equal, or y equals 2 squared, do we have to square it every time? Like, do you want us to square? You get what I'm saying?
No, I don't think I do. I'm sorry.
So, like, for example, I have y equals 3 squared. Like, when you have an x squared, whatever you put in for the x, do you have to square it?
On this one right here,
Yeah.
yes, because the original equation has it squared.
Okay. And
So
so I'll
you're
get the problem
doing,
wrong if it's not squared.
well, yeah, because you have to do whatever it says because you're plugging the value back into the equation, and the equation is squared.
Okay.
So you have to do that.
Okay.
Oops. I think I might have done this one wrong with Brooke.
Uh-oh. That's not good.
I mean, I got it close. I did 5, and for whatever reason, I don't know why I got 5. Why did I get 5? 2 squared is 4.
Okay, so I got a different number than you did, though.
You did? Oh, I know why. Because 4 minus 12 is 8, Miss Sparks. So I did do it right with Brooke. Praise God. So you got a 5?
Oh, not for that one. I'm talking about for 3, 4. I got 320. I got 22 as my y value.
Which?
For
Oh,
3, 4 for your vertex, the other point on the vertex.
okay. And how did you get that?
I'll just show you through the camera. Hold on one sec.
Okay, hold on.
It's just a lot
Okay.
easier to do that. There we go. Wait, I don't know if can you see it?
Hang on. Nine minus 18 plus 13. Well, 9 minus 18 is -9. And
Oh, that's
negative
right.
9 plus 13.
Okay.
So what you have is 9 plus 13, which is 22.
Okay.
And it's -9 plus 13. Does that make sense?
Yes, ma'am.
Okay. That's why.
It's
You
4.
got to watch your signs on that.
Yes, ma'am.
You know, because I don't want it to mess you up on something little like that when you do all the other math, you know?
Yeah. Yes, ma'am.
So if I do 2, 5 as one of my points, I know that the principle of symmetry tells me that 4, 5 is going to be a point on there also.
Yes, ma'am.
Okay,
So,
because it's going to be even across the axis of symmetry. Does that make sense?
yes, ma'am.
Okay, so that one's graphed because you really only need 3 points to graph a parabola.
Yeah.
And we're asking you to sketch the graph. So we're not looking for perfection really. You know,
Okay.
if you have
the label of the axis of
if you
symmetry.
have if you get the vertice and one additional point and then use the property of symmetry to match it on the other side, that's fine. But we kind of have to know that you're using that principle and see
Yes,
that
ma'am.
in your work. Does that make sense?
Yes, ma'am.
Okay. So on number 2,
Well,
the axis of symmetry.
I think I can get the graphing ones right now. Actually, I think the
You
ones
do?
that, yes, ma'am. I think the ones that we need to focus on are the
Factoring?
yeah, that kind of stuff.
Okay.
Yeah.
Okay. So on number 5, what 2 factors of 4 This is actually a perfect square also. What two factors of 4 multiplied give you 4 when you add them?
2.
Yes. So that one's fairly easy. So
And
you
that's
could
all we
write
have
it
to
like,
do?
yeah.
Oh,
Well,
wow.
on this one, I'm sorry, it's solve. My bad. All right. So you've got the two factors, correct?
Yes, ma'am.
Okay. So now each of those factors, or actually since they're the same, you only have to do it once. You set each little factor equal to 0 and solve for k. So k equals -2. And you're done.
Oh, okay. That's easy. Um,
And then 6, what two factors of 10, -10, which that tells you one's going to be positive, one's going to be negative, and the bigger one is going to be the positive one because this is positive. What two factors of 10, when you add them, give you a +3, but when you multiply them, give you a -10?
2 and 5.
Good. So +5 and a
-2.
-2.
So K plus, or no, sorry, not K, but N plus 5 equals 0 minus 5. So it's going to be N equals -5. And then you'll do that for N minus 2. So you're going to N minus 2 equals 0 plus 2 N equals 2. And
Perfect.
Okay. So I understand those.
All right. And then on number
16.
7,
Okay.
that's the difference of two. I mean, you're going to want a factor that's a small factor. What can I factor out of this one?
For number 7.
What is in both this term and this term?
1. Yeah, 1.
There's something else.
0.
Something else. It's a letter.
N.
Yes.
Oh.
If I take the n out, that's going to leave me n minus 4 equals 0. And I set the n equal to 0. And I set the n minus 4 equal to 0. So it's the answer is 4 and 0.
Okay.
Okay? Does that
Yes.
make sense?
Yes, ma'am.
Those are the ones that seem to trip students up. So be very cautious about those. Okay?
Yes, ma'am. I'll try to solve number 8 on my own.
Okay.
Real quick. Okay. Sorry, I tripped myself up there. I don't know, that was weird. Yeah, I got that.
You did?
Yes, ma'am.
Good job.
Thank you.
All right. Number 9. You want to make sure that the equation is in standard form first. And this is not in standard form. Standard form means that it's going to be in that the variables with the exponents will be in descending order on the same side of the equation. So I'm going to add 3x to both sides. Sorry about my dog.
All right. He saw the man down, so he started barking.
Yeah. My kids are just standing outside.
Oh,
I
okay.
wish they would just come in because they're making him crazy. So does that make sense to you now that it's in standard form? And now it's factorable.
Yes,
so what
ma'am.
I'm looking for is 2, and I did this earlier with Brooke because I know Miss Wynn teaches it via grouping. Do you want to see that? Or do you like figuring out, you know how you were doing, this is multiplication and this is sum over here?
Oh yeah, I did the
product?
sum thing. That's what I did better. Is the
Okay.
product within this sum.
Okay, so the product, 10, 1, and that would give us, -9 or something, so that's not it. If we do 5 and 2, that would give us, if we had a -5 and a 2, then that's going to give us a -3. So we're close, but we want this to be negative. So that will be positive.
Yeah.
Okay, does that make sense?
Yes, ma'am. I only use that for like the really big problems and that kind of
The
stuff.
big ones? Okay.
This one was easy, so I didn't really need to use
Okay.
it.
So you did x plus 5 and then x minus 2 equals 0. And then you should have -5. For your final answer, you should get -5, +2.
Yes, ma'am.
And you got that?
Yes, ma'am.
Okay, cool. Okay, so this next one, it's not in standard form either. So you want to first get it in standard form.
Okay.
Okay, so you're going to add that 8x to both sides.
Yes, ma'am.
And you're also going to add that 15 to both sides. So now everything's on the left side of the equation and it's all set equal to 0.
You wouldn't do x plus or x minus. You don't make it a -x because that's just more work.
Yes.
Okay.
I would try to keep my leading coefficient positive if at all possible when factoring. And then if I didn't, I would factor out that negative.
Yeah.
And then do it. So now I'm looking for 2 factors of 15 that when added together give me 8.
5, 3.
Yes.
X
Good
plus
job.
5, x plus 3. So you got x plus 5 equals 0. It's just going to be -5, -3. So
yes, sir.
Do I have to solve that out? Like show my work?
You do not have to solve that out. If you can visually see it and know that it's going to be the opposite, I am absolutely fine with you showing me that.
Okay,
I just want to see that your final solution is -5, -3.
Yes.
That's all I want to see. Does that make sense?
Yes, ma'am.
Okay.
I think
Okay, once again, this one is not in standard form. So you would want to move your 4p and your 3 over to the other side by adding them.
Yes, ma'am.
So I've got p squared plus 4p plus 3. And these equals 0. So it's going to be p plus 3 and p plus 1 equals 0, because you're looking for two factors that multiply together to give you 3, that when you add them give you 4, which would be 3 and 1. So my final answer is -3, -1.
Yep.
And when you work those factoring worksheets, the more you do this, the easier it will come to you, because you'll be tapping into that part of your brain where all the factors of your multiplication facts are just readily there, which will help immensely. Have you taken the ACT or SAT yet?
No, ma'am, I have not.
Okay, that'll help on that as well.
Okay. I think we can skip ahead of these problems or understand
Just
them.
remember on this one right here, it's going to be a little freaky because you're going to get m squared minus m equals 0. And you just want to factor out the m. It's a tricky one too. So you've got m equals 0 and m equals 1. Okay?
Okay. Here, I'll just do that one real quick.
It's just a little bit different.
Yeah.
It's kind of there to kind of, it could trip you up, is what I'm saying, easily.
Yes, ma'am.
Don't overthink them.
Okay.
Did you do 13?
Yes, ma'am, I did.
Okay. All right. Now we want to look at number 14 and figure out, is there anything that we can factor out? And there isn't. So we're going to do the slide and divide.
Okay, so slide your 5 all the way to the 24.
And then that's going to be
x
x
squared
minus 26
plus
x plus
24.
120, I think.
Yep, 120.
So now this is the one where I think you like to do this little thing where it's the products, right?
Yeah. Yes, ma'am, I think so. I can't remember, honestly.
So you're looking for all of the different factors that multiply, and then this is the sum. So 120 and 1, 60 and 2, 30 and 4, which if I look at 30 and 4, that if I do 30 minus 4, I'm going to get 26 and negative 26. So there it is. That's the one we want. There she is. So we've got x minus 30 and then x plus 4. And so now we've slid, and now we're going to do our dividing thing. So we've got to divide both of our factors by 5. So 30 divided by 5 is 6. So that's that factor simplified. But 4/5 doesn't simplify. So we're going to swing that 5 over in front of the x. And there's our two factors. But we still have to get our zeros or roots or solve it. So we know that this is going to be 6. But this one's a little more special in that we might have to write it down just to make sure we do it right. So we've got 5x equals -4. Divide both sides by 5. And that gives us -4/5 as our other answer. That's what I meant by there were no fractions in the graphing, but I couldn't guarantee there wouldn't be on this part. Does that make sense?
Yes, ma'am.
I don't want to start on the next one till you're ready. Are you ready?
Yes, ma'am.
Oh, okay, good.
Oh, wait, you got it wrong, though.
I did?
Yes, ma'am.
What'd I get? What
what
did I do wrong? Not that I disagree, but
you did plot +6 and -4/5, but remember we have to make it the vice versa. It has to be -6 and +4/5.
well, I got a -6 in my factor. So wouldn't it be a +6?
Oh, I see that. My bad. That was me. Yep.
Okay. All right. I'm not saying I can't get them wrong. I'm just saying.
No, I get you. I thought we had only positives, and so I messed up.
Maybe I did. Did I get it wrong?
No, you got it right. I thought you got it wrong, but you got it right. I got it wrong.
I don't know. Maybe I don't know. Now you got me paranoid. I'm just double checking everything.
No, it's okay.
Did we pick the right factors?
Yes, ma'am. Yes, ma'am. Okay. We did.
And did I write the problem down right?
Yes, ma'am.
Okay. All right. So we're going to slide and divide. I did something wrong.
What'd you do?
It's the two factors that multiplied together give you 120, but it's a positive 120 and a negative 26. So I didn't get the factors right.
Yeah, you do. You put a negative. You made it a negative
well,
30.
But if you multiply a -6 and a +4, you get a -24. So I need to keep working on my factors. My factors still aren't right. Are you with me? You understand what I'm saying now?
It's a -4. So I was right about the +4/5.
Well, the factors are all wrong.
Not really. You just have to make it two negatives.
that would make it a negative 24. It would make it a negative 120. And we're looking for a positive 120. So both of my factors have to be positive. So actually,
when you wrote the problem, it was
20
wrong.
and 6. Yes, it's 20 and 6. Not 30 and 4. Wow. Does that making sense? I am really sorry that I did that to you. But that will tell you how you have to watch your signs on this for sure. Because it takes two negatives to make a positive. And I did a subtraction thing. And I really needed to be doing an addition. I need to be combining a positive instead of 30 and 4. That was so close because it comes up to be 26. It's 20 and 6. And both of them have to be negative. So it's x minus 20 and x minus.
What?
Or did I completely lose you because of what I did?
No, I'm there.
Oh, praise God. I'm so sorry, Braden.
No, it's all good.
And then that's why you really have to watch those signs. I guess that's proof, isn't it? Then you divide both by 5, and you've got x minus 4, and then 5x minus 6 equals 0. And now, if you set x minus 4 equal to 0, you get a positive 4. And if you set this one, 5x minus 6 equal to 0, you're going to get a positive 6/5. So those are your two answers, 4 and 6/5.
Okay.
So you really got to watch those signs. Man, that was so close.
Yeah.
Positive 70. They quit writing on me. Yeah, it quit writing on me, so I've got to reload it, unfortunately. Gotta love the internet. All right, hopefully this will work better. Nope. Okay. Okay, plus 70, because I'm going to slide. And now I'm looking for the two factors of positive 70. Watch it, Mrs. Sparks. A positive 70 that give me a negative 19, which that tells me both of my factors are going to be negative, because the only way I can get a negative the only way I can get a negative sum and a positive product is by two negatives. Give me 70. So I'm going to start with my factors, and I know this is how you like it. So I've got 70 and 1, 35 and 2. I've got, let's see, 15 and 4. So there's our answer, right? No, that's not
Yes,
15 and 4. It's, that's not it though. 15 and 4 is 60. So that's not it. 14 and 5? 15. Yeah.
Yep.
14 and 5. There we go. Gives me 70.
Negatives.
All right. So now I've got x minus 14 and x minus 5. So now I've got my factors. And I've done my slide. Now I'm going to do my divide where I divide the leading coefficient, which then that gives me x minus 2. And since this doesn't come out to be a pretty fraction, I've got 7x minus 5 equals 0.
Okay.
So then I know that my answer is 2. And then I take 7x minus 5 and set it equal to 0 and solve for it. So my final answers are 2 and negative 5. And positive 5/7.
Wait, could you scroll down real quick? Because I can't see.
Absolutely.
There you go.
And then after this, it's all that special pattern factoring. How are you on that?
Hold on one sec. So, okay. All right, I'm ready for 16.
Okay. This is that special pattern factoring. So what you want to do is when you only see two numbers or a binomial, if you will, you want to check and see if your first term is a perfect square, if your last term is a perfect square, and if there's a subtraction sign in the middle. So is 4p squared a perfect square?
Yes, ma'am.
Okay, what is the square root of it?
2.
And
2 and 2?
No.
2, but I'm confused. Oh, 2 and p.
Yes, so 2p. Okay, and what is the square root of 25?
5.
So this is the sum or the difference of two squares. And it's that special factoring pattern because that middle term is going to cancel out. Remember that? The difference of two squares. It's a special factoring pattern.
Yes, ma'am.
Do you remember that?
Yes, ma'am.
Difference of two perfect squares. Number 17 is the same. Do you want to see if you can do that one and tell me what to write?
Yeah, I'll do it by myself real quick.
Okay.
It's just 3a plus 2 and then 3a minus 2.
That's it. Perfect. This is a very, 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 very important concept when we start working with something later on called conjugates, it is all based on the difference of two perfect squares. So it's very, very important.
Okay.
Okay, the remainder of the page, 18, 19, and 20,
Yes, ma'am.
is perfect squares. So when you have a trinomial, which is what you have here, 3 terms, you want to check your first term and see if it's a perfect square, and your last term and see if it's a perfect square. And 25n squared is a perfect square, with the square root being 5n. And then the square root of 4 is 2. How you double check to make sure that you're right? What is 5n times 2?
25. No,
5n times 2. 5,
10.
5n times 2. I'm sorry?
10N. Sorry, I had it on 10N. Yes, ma'am.
So 10n. So if I double 10n, I'll get 20n, which is that middle term. So you know you're right.
Yes, ma'am.
Okay?
Yep.
All right. So what do you think the answer to number 19 is? What's the square root of 16n squared?
4N.
Right.
3.
All right. And what's the square root of 3? I mean, 9.
30.
Sorry. Huh?
It's 3.
Okay. But this term right here is negative. So what do you think that's going to tell you about what's the 3? What's going to be in front of the 3?
A negative.
That's right.
So what is going on with the B value? I'm kind of confused about it.
For the B value?
Yes, ma'am.
Okay. You're actually doubling. That's why I had you multiply 5n times 2. Now multiply 4n times negative 3. What do you get?
Negative 12.
Multiply this times this.
Negative 12n.
Okay. And now if I double that, what do I get?
Negative 20, or we're multiplying. Okay, never mind. I was gonna say negative 24.
That's right. So that the middle term is the product of those two doubled.
Okay.
Okay, because basically here's what the pattern looks like, but none of you students really like it when I write the pattern out, but this is what the pattern looks like. The first term, which is called a squared, and then the last term, which is b squared, plus those two, ab, doubled. That's what this is. And this as well. Does that make sense?
Yes, ma'am.
You're doubling the product of the two.
Okay.
If you foiled this out, if you wrote 5n plus 2 times 5n plus 2, you would get 25 squared, 25n squared, plus 10n plus 10n plus 4. And then you would combine this
Yes, ma'am.
to be 20n. Does that make sense?
Yes, ma'am.
Okay. So why don't you factor this last one?
Okay. 102 times 36. And
Okay, well, just take the square roots first. Don't work that hard.
It'll
Just
be
take the square root of the first term. What's the square root of the first one?
well, I think I got the answer, which is 3r plus 1 squared. Well, like that's in a
Oh,
parenthesis.
good job. Good job. I got you. Sorry about that.
You're good.
Yep, that's it.
Awesome.
And I think that's the test, right? Yeah.
Yes, ma'am.
So it's not too bad. The last 5 are factoring patterns. So that's not that bad. And there's only 2 slide and divide.
Yeah.
And the rest of them all have 1 as a coefficient. You just have to make sure you know how to get it in standard form.
Yes, ma'am. All right. I think that's all I needed help on today.
Okay.
So thank you for your help.
Oh, not a problem. Thanks for coming to Math Lab. Thanks for working so hard.
Yes, ma'am. No problem.
You have a blessed afternoon.
Alrighty, you too, Miss Vargas. Have a good day.
All right. Bye-bye.
Bye.